In learning target 3, we're simplifying expressions using those identities that you have. Therefore, you have to know the identities to be able to do this. So, what we're going to do is we're going to take all of the pieces of whatever we have, and we're going to probably switch them out for different identities. So we're going to do lots of substitution in order to make this a smaller expression. So instead of having a fraction, or instead of having an addition problem or multiplication, we're going to try to get it down as small as we can. All right? So first one, we have cosecant theta over cotangent. So you just start thinking about how you can kind of put them in terms that things cancel out. So for example, cosecant theta, everyone should know is the reciprocal of sine. So cosecant is the same thing as 1 over sine theta. Cotangent theta has two things on that identity sheet you could use. 1 over tangent theta, but then I have sine and tangent, so nothing cancels out there. Or cotangent is cosine over sine. So now I have a sine in each one of the pieces, and maybe that will go away. So whenever I'm doing these problems, that's what I'm thinking through. I'm thinking through what identities I have to use, how I can use them, and how I can use that to simplify. So I'm going to rewrite cosecant as 1 over sine theta. And I'm going to rewrite cotangent as cosine theta over sine theta. So I'm dividing fractions. So dividing fractions is really multiplying by the reciprocal. So I have 1 over sine theta times sine theta over cosine theta. So now I have a sine in the numerator and a sine in the denominator, and I can cancel those out. And so I'm left with 1 over cosine theta, and that would be nice if I didn't have a fraction. So 1 over cosine theta is the same thing as secant theta.
When you multiply by the reciprocal, you flipped it, right?
That's what reciprocal means.
Well, what about if you just cross multiply?
You can't cross multiply. There's not an equal sign.
Not cross, like cross.
You can't cross multiply unless there's an equal sign. Yes. 1 over cosine theta is secant theta. You're going to know those identities so that you know that's secant theta. You guys have known the reciprocals of cosine and sine since geometry.
Yes.
So it's not from yesterday. Other questions on the first one? We can do another. Other questions on this one? All right, on 15. I have cosine x, I have cosecant x, and I have tangent x. Again, it would be nice if I could get them all into the same terms, same trigonometric function, something. So if I start thinking about it, cosine I could change to secant. I don't know if I need to yet. Cosecant, I can change to have sine, right? Tangent can be sine and cosine. So I can get these all into terms of sine and cosine. So that's what I'm going to do. So I'm going to leave cosine x alone, because I can make everything else have a sine and a cosine. Cosecant, the reciprocal is sine, so I have 1 over sine x. If you need to put this over 1 to understand what's going on, you can. And then tangent is sine x over cosine x. So if I start looking across, I can start canceling some things out. We're just simplifying the expression. So I've got sine x cancels out, the cosine x's cancel out, so you get 1 over 1, which is just 1. 1 divided by 1 is just 1. It can't like completely disappear, right? So when I cancel out the sign x's, I'm actually getting 1s.
This. That way you know what to plug in, but you don't get this one. You have to memorize all this.
Okay, last one. The last one's a little more difficult. All right, so I have cosine x plus cotangent x, sorry, cosine x times cotangent x plus sine x. So there's a plus sign in this one. So I'm going to leave the sine x alone for a second, because if there's a plus sign, I can't do anything. I can't just cancel stuff out. It's not being multiplied by everything else. So a cosine x and a cotangent x. So cotangent can be two different things. If you look at your identities. It can be 1 over tangent, but there's no other tangent in this problem. And cotangent can also be cosine over sine. And there's a cosine and a sine in this problem. So I'm probably going to use cosine over sine because then everything has the same trig functions in it. If I put 1 over tangent, I'm introducing a tangent that has nothing to do with anything in this problem. Okay? So I have cosine x, and I have cosine x over sine x.
Wait,
Mm-hmm.
how do you know we that
When you're thinking through this, you're trying to simplify. So you want everything to be in the same types of trig function. So if I change it to secant, then I have the secant, and everything else is cosine and sine. So you kind of think through the identities first, think about it, to make a plan, and then try to go with the best thing. If you change it and it doesn't work, change it back. Now, nothing cancels out here. All right, nothing cancels out. But I have nothing else that I can do, so I'm just going to go with it. So I'm going to multiply. So I have cosine squared x over sine x.
Wait.
And I have this plus sine x. I haven't made this any simpler, right? But I'm just doing what I can. I'm trying to try different things out. It would be nice if you could add these two together, right? Because there's a plus sign. So it'd be nice to put it all together in one term. If I'm going to do that, though, I need to have a common denominator, right? I'm going to have a common denominator over here. So what am I going to multiply by? Sine x over sine x. Because that way you have a common denominator. You're multiplying, remember this is 1. So I'm multiplying by 1, I'm not changing anything, putting it in a different form. So I have cosine squared x over sine x. And then I've got sine squared x over sine x.
Why do you get this? So, can you just add it all?
Yeah, I'm not done yet. But you would.
So are you going to get cosine?
One sec. Yes, Nick.
So the sine x on the being added to the
Mm-hmm. This one.
so we are multiplying by
We're multiplying by sine x over sine x, so we have a common denominator. So we could actually add them. All right. So we can actually add these two things together now. Put it into one term. So I have cosine squared x plus sine squared x over sine x. Again, this looks like a hot mess, but it's got a purpose. If you look at your identity sheet, cosine squared x plus sine squared x equals something else. It equals 1. So you end up getting 1 over sine x. That looks a lot better than what it looked 5 seconds ago.
Well, wait, wouldn't the denominator be, if you're adding them, wouldn't it be 2 sine x?
When you're adding fractions, you don't add the denominators.
so you get 1 on top.
Right, because cosine squared x plus sine squared x equals 1. It's on your identity sheet. So I'm just substituting it in, because they're equal to each other, right? So then 1 over sine x is cosecant x. All right. That's all the examples I'm going to show you, because like I said the other day, I cannot do every single question ever because they're all different. A lot of your homework will be like the first two examples. All right, so Learning Target 3 assignment is on your page, but I will say 47 and 50 are going to be a challenge. On 47, it shouldn't be a challenge, but you guys kind of forget algebra rules sometimes. So on 47, you're going to have to FOIL. You guys all know how to do that. Okay? And if you FOIL, you'll be on the right track and then it'll be fine. If you don't FOIL, then you'll get lost and you won't know what to do. All right? And then 50, when you get down to it, we can talk about it. I'll probably do 50 in class one day just to make sure we're on the same time. Okay?